Welcome to the assembly video of BWP Group's full-scale 3 megawatt axial air gap air core generator. As you will see in this video, the generator is 12 meters in diameter and made up of 12 segments. The following video will showcase the simple, step-by-step assembly process and tooling designed for manufacturability and automation at scale. The assembly process describes magnetizing BWP Group's patented flux-focused permanent magnets, assembling a magnet pole, placing a pole on the rotor back iron, assembling a rotor and stator segment, assembling a rotor-stator segment to the generator hub, and finally, installing the stator support spokes. Magnets are not handled directly by humans after magnetizing for safety reasons. Each individual magnet is made of 3 pieces. The 2 outside pieces are made with angled magnetic domains to focus flux across the air gap and minimize leakage between adjacent poles. The top surface of the magnet is distinguished by notches for retainers. North poles are inserted into the non-metallic jig and placed into the magnetizer with the notched surfaces up. 5 total magnets make up 1 pole. After magnetizing, the magnetized part is slid down the non-metallic rail to the 3D Helmholtz coil, where its 3D field is measured and recorded. Each magnet is serialized and its location in the generator is recorded for future validation. Serial numbers are traceable to the magnet powder lot numbers. The 5 magnets are slid into an aluminum corral that uses a pneumatic cylinder to squeeze the 5 magnets together so they touch from end to end. Once the magnets are squeezed together, a tool called the picker is used to pick the 5 magnets up and place them on the back iron. The picker has aluminum pins that restrain the magnets in 2 directions and uses a steel plate to magnetically hold them in place in the vertical direction. The steel plate is initially held a few inches away by aluminum pins that are positioned by a small hydraulic cylinder seen on top of the picker. Once the side pins have captured the 5 magnets, side to side and end to end, the aluminum pins are retracted and the magnets are allowed to contact the steel bottom of the picker. Once the magnets are attached to the picker's steel underbody, the corral side rails are pneumatically separated to allow the picker to lift the magnet out of the corral. In preparation for the arrival of the next pole, the previously installed poles that will be neighbors of the next pole are restrained by temporary straps to prevent them from jumping to the next pole. Poles are located between the aluminum separators that can be seen on either side of the picker landing bushings. Poles are placed by the picker using a set of guide pins that are aligned to pass into guide bushings in the fixture holding the back iron. As the picker is lowered to the back iron, it lands on some elastomeric bushings to limit the effects of the rigging chain slack being pulled tight and other structural deflections as magnets approach the back iron. This allows the picker to place the magnets on the back iron by simply reversing the process used to pick the magnets from the corral. Once placed, the aluminum pins push the magnets off the picker's steel underside and establish a large air gap, which frees the picker to go pick the next pole from the corral. Once the poles are all installed on a pair of matching back iron assemblies, they can be mated with a stator section to complete a generator segment using the stationary and moving platens. First, a back iron assembly is attached to the stationary platen. Next, a stator segment is hung on a set of guide pins between the two halves of the rotor segment. The moving platen is pushed using a double-acting hydraulic cylinder towards the back iron on the stationary platen. When it comes within approximately 8 inches of the stationary back iron, a separate set of cylinders mounted to the stationary platen are used to counter the attractive forces between the two back iron assemblies and control the final inches of travel. Completed stator segments are assembled using a set of fixtures that ensure the overlapping stator boards are correctly aligned, and once all the structural locating features are engaged, the fasteners are installed and tightened. For the final segment, a unique fixture is used as the process is much like putting the last slice of pie back into the pie tin. The fixture pulls the last segment radially inward into its final position. Lastly, the structural spokes that connect the printed circuit board stator segments to the hub are installed, and the radial locating pins are removed. The structural spokes support the stator mass and locate the stator segments in the radial direction. The air gap control system maintains the stator boards axially centered between the rotors. Once the electrical connections were made and instrumentation was installed, the unit was rotated by hand. A few of us pushed on the lower rotor to get it to rotate. The back EMF was recorded during the coast down period and compared to the predicted back EMF from our analytical model. It matched to within half a percentage point. The generator's rated speed at full load was 13.3 RPM at 3 megawatts. Thank you for watching, and please reach out with any follow-up questions.